Hello and welcome to my channel Code with Vinay. Today I am going to teach you how to compute the LCM of multiple numbers in Java. In this video, first we'll develop a method in Java to compute the LCM and then perform some optimizations to make it faster. LCM stands for lowest common multiple. It is the smallest positive integer that is a multiple of two or more integers. In other words, LCM is the smallest number that can be divided by two or more given numbers without leaving any remainder. Notice that LCM is the smallest positive integer that is divisible by all the numbers of which we want to find the LCM of. So the result must always be positive. In the case of a negative number, we can ignore the sign and calculate as if everything is positive. For the sake of simplicity, here we'll assume that all the numbers are positive. Let's find the LCM of 5, 8 and 16. And for that, we need to list the multiples of 5, 8 and 16. The multiples of 5 are 5, 10, 15, 20 and so on. Similarly, the multiples of 8 are 8, 16, 24 and so on. And finally, the multiples of 16 are 16, 32, 48 and so on. Now, if you notice over here, the minimum or the lowest common multiple is 80. And hence, 80 is the LCM of 5, 8 and 16. So, our initial approach will be to take a variable for LCM, initialize it to 1, and then check if it is a multiple of all the numbers of which we want to find the LCM of. If it is, then we have our LCM. Otherwise, we'll increment our LCM and again check if it is a multiple of all the numbers in our list. We'll repeat this process till we find our LCM. Since our list is assumed to be positive and we are going up from the lowest possible value, our first common multiple will be our lowest multiple also. Let us dive into some coding and try to implement this logic. In order to save some time, I have already written some code. So here I have a class by the name of lowest common multiple. Within the class, I have a main method. Within the main method, I am having an array by the name of A in which I am storing the numbers of which I want to find the LCM of. That is followed by invoking of the method getLCM, and we are passing our array A as an argument. Now our getLCM method is defined over here. The function getLCM will return an integer, that is our answer, and it will accept an integer array like I've already shown to you. And within the method we have taken a variable LCM which will ultimately store an answer, and then we'll return our answer which will be displayed by the system.out.println inside the main method. Let us code the logic which I discussed. For that, we'll begin by taking a loop. I'll say int I is equal to 1. Then the loop will be infinite and then we'll move up from this value. Now please note, we are beginning from 1, we'll keep on increasing the value of I, and since we are assuming that all the numbers are positive, there will come a time when we'll get our LCM. Now within this loop, we have to check whether I is the multiple of all the numbers stored in an array or not. We have to find that, and for that, we'll take a Boolean variable. I'll call it Boolean found, and then in the beginning, we'll assume that we have found it. So we'll say found is equal to true. And then I'll run a loop for all the elements in the array. For that, I'll say int x is equal to 0, x is less than a dot length, and finally x plus plus. And then we have to check whether or not I is a multiple. And for that, I'll say that if I modulus a of x is not equal to 0, that means if it is not a multiple, we'll say we haven't found it. So found is equal to false. and then we'll break out of the loop. So I'll say break. Now outside this loop, that is over here, I'll check whether or not we have found the number. That means whether or not I is a multiple of all the numbers stored in an array. For that, we'll check that, okay, if we have found it, we'll say that our LCM is I. So I'll say LCM is equal to I. And then we'll finally break out of the loop. If we have not found it, then we'll go up again, we'll increase the value, and then again do this whole procedure. Now I'll reformat this code, save it, and then we'll run it. So let me compile the code. So I'll compile the code and the answer is coming. We have our answer as 80. Now, getting the correct answer is the minimum requirement of any program. What is the use of a program which doesn't even give the correct answer? The skill is not in getting the correct answer. The real skill is in getting the correct answer in an elegant and efficient manner. So let us try to improve this code so that we can reach the answer efficiently. Right now, our search for the LCM is beginning from the number 1. Notice that lowest common multiple of a list of numbers must be at least equal to the maximum number in the list. For example, in case of 5, 8 and 16, the LCM cannot be less than the maximum number 16. That is, our search for the LCM should begin from the maximum number if we want to make the program efficient. Let us incorporate this in our program. So let us find the maximum value now, and for that I'll introduce one more variable and we'll call it max. The initial value of max will be equal to the first value of our list of numbers, and then we'll run a loop to find the maximum number in the array, and for that I'll say int I is equal to 0, I is less than a dot length, and then I'll say I plus plus. And then within the loop, we'll find the maximum. We'll say that if a of I is more than max, then we'll say that max is equal to a of I. Once that is done, I'll reformat the code. And then instead of starting from 1, I'll start from max. Now, let us run the program once more to see whether it is still working or not. So let's run the code once more. And there we are still getting 80, which is the correct answer. Another thing to notice is that our search for the LCM is increasing in steps of 1. That is, I is increasing very slowly. However, since we are talking about multiples, we should ideally increase in steps of the max value rather than 1. And that will considerably improve the efficiency of the program. So let's make this improvement also. So instead of I plus plus, we'll say I plus is equal to max. And then we'll again run the program to see if it is still working or not. So we go over here, we run the program, and as you can see, we are still getting the correct answer, but this time the efficiency of our program is much more than before. So now we have an efficient program to calculate the LCM of a list of numbers. The only deficiency is the assumption that all array elements are positive. The obvious way to remove this deficiency is to change the negative numbers into positive, and that can be easily done now inside the loop where we are finding the maximum value. But the arrays are passed by reference. That means if we change the values from inside the function, the original array will change, and that is something which the user will probably not want, as he or she is just trying to get the LCM. Instead of making the negative values into positive in the original array, we can create a new array and copy the values passed into the new array. We can do this manually, but I would like to use this opportunity to show you another way of doing this via the clone method. So let's see how we can use the clone method. For that, what I'll do is I'll first change the name of the array from A to B. Then I'll create another array with the same old name, that is A. And then I'll say A is equal to B dot clone. And this will make a copy of the array B into our array A. and then we'll make the values positive. So for that we'll check. We'll say that if a of I is less than 0, then we'll simply say that a of I is equal to minus a of I, and that will change the sign to positive. And I'll just fix this typo over here. So that's it. Again, the output is not going to change. Let's confirm that by running the program once more. And as you can see, we are still getting the same old answer, 80. We can improve this program further by using the variable argument method to allow the user to call the function without using an array. I have already discussed the variable arguments method in a separate video some time ago, and you can find the link to that video in the description below. For that, no major changes are required. I just have to say int ... Then I'll remove this box bracket from over here. I can go over here and then I'll call this again, but this time instead of passing the array, I can say 5, minus 8, 16. And now if I run the program, the output will still remain the same. The only change I have made is that I'm using variable argument method now, and one of the values is negative. So if I run the program again, there we are still getting the answer, 80. And that's it. You now know how to compute the LCM of multiple numbers in Java in an efficient manner. I hope you found this tutorial helpful. See you in the next video. Till then, happy coding. Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. You can follow me on the internet on any one or all of these channels.